You. So remember this slide actually we talked about on Friday that you need to memorize the name and the symbol. For instance, if we pick number 56, I brought my periodic table. So number 56, barium, Ba. So you need to know barium, Ba. Okay. But the periodic table was, the video said, he basically said if he goes every 7 and then comes back around, now you're like 7, how does that work out? Well, let's pick on CK, K is the symbol for what? Potassium, yep. So if you go across, let's go potassium, calcium, let's skip the SC through the zinc. Let's go potassium, calcium, let's go to gallium, germanium, arsenic, selenium, and bromine. Okay, so actually that is 7 right there. 6, let's see, 1, yeah, 5 plus 2 is 7. Now notice that what I skipped, and you're gonna have to kind of turn around and see this, but what I skipped just now was actually these. These are, we're going to have a slide coming up here in a minute, but they're kind of indented. Actually, they're called the group B elements. So he went dot, 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 dot. Sorry, that's 7. And found some similarity there. Now, the thing about it, and we're going to see this in Thursday's lab, is the similarities he was looking at was its combination with oxygen. And check out these guys over here. This last one, they don't like to combine with oxygen. They don't like to combine with anything. So I kind of tell students it's kind of like days of the week. Like if you line your calendar up, or a calendar is lined up with, Sundays, Mondays, Tuesday, Wednesdays, Thursdays, Fridays, Saturdays, okay? So you basically know all of your Sundays are like, all of your Mondays are alike, etc. Then we have these 5 days of the week, okay, and then you go on to your, Saturday. And then you whip back around and you're back to do it again. And the calendars are lined up so that actually these days are very similar. These days are very similar. These days are very similar. Okay, you get the idea. So that's actually what Mendeleev came up with. It's called the Law of Periodicity. And the law, if something's periodic, it basically comes back around. So that's to say, what he found out is if you go across 7 days, 7 elements, it comes back around to repeat itself. Okay, the law of periodicity. And so I'm going to try to convince you, but it's really good when you look at, there's a lot of good things about the periodic table. And one of the good things is to look at, we're going to call these actually groups, to look at something in the column and to just know that it should behave similarly. So one of the things that, and you'll see this on Thursday, that Mendeleev ran into was he had some gaps. Like not all the elements were discovered, and there were many more to come. But the gaps, he could anticipate kind of the properties of the elements that hadn't been found yet. That is so cool. Okay. So you need to know your way around the periodic table a little bit for this unit of material and kind of going on out throughout the course. Every good periodic table should have a JAG. When I first got here, there was a periodic table in the room that I was lecturing in that did not have that JAG, and I was like, are you serious? So if I talk about a JAG, that's exactly what I'm talking about, okay, that black line. Now the periodic table I gave you the other day clearly has the JAG, okay, and remember that's the one actually I'm going to give to you when you come take your test. Okay, cool. Notice when we talked about this, when we've talked more about this, that it's arranged that, it goes from left to right, just like you read. And when you finish one, we're going to call these period. When you finish one period or one row, you go back to the beginning. And we said that actually it's kind of interesting that there's a kind of a gap here for element number 57 and 89 kind of skips, and their rest of the guys are down here. I was playing that periodic table that I showed you on Friday that's online, the web PT. that periodic table actually has a little radial dial that you can click and it says expand or normal. And if you expand it, basically it takes what we call the lanthanides and the actinides and puts it back up in the periodic table. So I think that's kind of neat. It's the little things. Okay. So what that jag does is to separate what we call metals and nonmetals. Okay. So you're going to want to know this. Kind of, it's a player in chemistry. You know, the identity of an atom as a particular element is important. And in terms of it being a particular element, whether that element is a metal or a nonmetal. So hopefully you would say that most elements are metals, okay, and there's only a handful of nonmetals. Sometimes when I get to lecturing, I'll kind of talk about this section over here for nonmetals. To me, it kind of looks like an upside down kind of right triangle. Okay, those are nonmetals. Now, you might think, I know what a metal is. I know metal is an iron, a stainless steel, blah, blah, blah. But you might be curious that, like, for instance, magnesium is a metal. You're like, I didn't know it was a metal. Well, yeah, it is. Okay? Carbon is a nonmetal. Carbon is right over here. Okay, so know kind of that stair steps. Okay, so now there are a handful of, remember I told you because of the law of periodicity, we definitely have this column thing going on, okay? Oh, sorry. This one. The ones along the jag, sorry, are actually kind of, they're hybrid, okay? They're kind of between metals and nonmetals. So the ones along the jag we call metalloids. And metalloids have some kind of cool characteristics. But I kind of tease because depending upon which chemist you ask and what time of the day it is that you ask the chemist, they might pick kind of a different handful of metalloids. But boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. I should show you guys, maybe I will on Wednesday. Yeah, astatine is AT. That there's this game out, an app called Quiz or QuizUp, Quizlet, I don't know, but it's kind of addictive. You play with people around the world and you pick different, it's kind of like you pick different topics to go on, and chemistry is kind of fun. So, all right, so those are metalloids. Now this is where I thought it was. Okay, so up and down we call these groups. Okay, so up and down we call these groups. And at the top of the column, or at the top of the group, is their group name, or group number, group identity. Okay, so we're kind of going along the B's there. There's 1B, 2B, and then the A's actually kind of are on both sides of the B group. So we have 3A, 4A, 5A, 6A, 7A, and 8A. Okay, so those are groups. Those are important. And then there's other ways to chunk up the periodic table. We can talk about the main group elements. Okay, main group elements, and sometimes I'll call these group A. Group A elements, not so surprising why that would be. Okay, so we have 1A, 2A, 3A through 8A. And then we have kind of the indent right here. These are group B elements. Their group all starts with a, or ends with a, or is it a type of B group? Okay. So sometimes I call them group B. They're also called the transition elements. And then these down, oops, it must be coming up. I guess I'm coming up on. Okay. So we have groups are the columns, and the rows are periods. Okay, the rows are periods. So on that periodic table that I handed out, just along the side, actually it's on this one too, are little tiny numbers. So like rubidium is period 5, cesium period 6, francium period 7, and all across here. So actually, if we wanted to pick on SN, SN is the symbol for tin. Okay, we could say that it is in group number 4A. Oh, sorry. Yeah. It's in 4A. I know this is screwy, but it's in 4A, and it's in period 5. Okay? I need to fix this. This is unconventional. But you can kind of see where I'm coming with that. 4A, okay, and period 5. What else we got? Oh, see, we forgot those two things along the bottom, those kind of inserts. And actually, when we get to talk about electrons around the nucleus of an atom, these guys are special because we're loading what we call F-block electrons when we kind of scoot across these guys down here. But these are called the, they're collectively called the inner transition elements. And this slide doesn't say it, but I'm telling you now. They're called the inner transition elements. Because these are called the transition elements, these B, and these are the inner transition elements. Now, right here, this right here is called the Lanthanide series, okay? Because it inserts right after lanthanum. Yep. And then this one right here is called the Actinide series, down here, because it inserts right after actinium. And yeah, I think we might have mentioned that actually, I'm pretty sure that all of these, as of the last, I don't know, couple months or so, all of these actually, there are elements in each one of these. Like finishing up period number 7. So it's kind of fun. It's exciting, starting a new period. It's no small thing. Okay. Oh, see, I did have it on slide. So collectively, the Lanthanide and the Actinide series are called the intertransition elements. I did have it on a slide. Okay, so these are just ways to chunk up the periodic table, looking at it differently. If you're like me, one of the things that drives me nuts, I have a hard time almost reconciling it, is if this is the JAG, oops, let me do a different color. If this is the JAG, okay, notice we have things like group, for instance, 4A. Notice it has some nonmetals, and it has some metals. Heck, it even has some metalloids. So yes, you definitely have that whole thing going on within one group. All right. So there are a handful that you need to know the name for. So remember, groups is what's got it going on. So you need to know 1A, the name for group for any element in one, or the name for the entire group are called the alkali metals. You need to know that. You need to know 2A are the alkaline earth metals. Did you guys get that? Probably. The way because they seem similar to me, the alkali metals and the alkaline earth metals, the way I remember the 2A is it's got actually two names to it, alkaline earth. And you guys did this little bubbly thing, in like on one of our first experiments. You guys took calcium metal and threw it in water. All right. And then we skip a bunch of columns, a bunch of groups, or sometimes groups are called families, which is kind of fun. And then we go clear over to the 7A, almost off the periodic table, and those are the halogens. Halogen lights, right? And then last but not least, there's some examples of some halogens. Remember chlorine, actually a lot of the halogens, kind of rings a bell. We talked about fluorine is a diatomic, chlorine is a diatomic, bromine diatomic, iodine diatomic, astatine not a diatomic. This is kind of neat down here. I think chemists just do this just to play, but I2 is usually a solid, and if you add heat to I2, it doesn't melt. It doesn't go from solid to a liquid. It basically goes from a solid to a gas. And so here it is in its gaseous state, and then here it is resolidifying. Kind of on the, they've just taken a round bottom flask and put some ice in it, so it crystallized there. I think that is so cool. So we call it sublimation when it went from solid to a gas, and we call it deposition when it went from a gas to a solid. I think that's neat. Okay, so the last column, you need to know the names. Actually, it's got 3 names, which is kind of annoying. Okay, they are called, I think the first 2 kind of go together. The first 2 names, they're either called noble gases or rare gases. Nobility is like kind of awesome, and rare is like rare, okay? They are rare on Earth. And then the other one kind of goes back to what Mendelev's problem was, is that these elements, and we'll talk, some of you maybe already know why, that neon, argon, krypton, xenon, and radon, why they don't want anhelium. They don't want to participate in any sort of chemical bonding because they're already just happy with the electrons that they have. So they're what we say inert. So they're inert gases. So I don't know how serious it is, but I do know we had a helium shortage like a few years ago. Helium used to be, you know, when in times of war and stuff like that with Hindenburg and all that, helium used to be maybe an asset that the military was interested in. And so we had it, you know, a national asset sort of thing set aside. And then that was lifted, and the helium Earth has is the only helium it's going to get because we're not making any more helium down here. So anyway, so there's a periodic table, kind of a colorful look at, remember there's only 2 liquids and they're shown here. Hopefully you would tell me that most elements are solids. Okay, there's liquid Hg, mercury, and there is liquid Br2, bromine. There's some kind of grouped here. The first one, I mean, this is classic metals right here, you know. And actually, I think I have a slide coming up. If you think you know what a metal is, you're probably right. Okay, metals tend to be shiny, and you can, they're what we call malleable. You can make them into sheet or make them into a wire. If you were to find these 2 elements on the periodic table, they actually are both kind of lined up. Those are halogens. They are definitely on that side of the jag, the little triangle. Those are nonmetals, and silicon is an example of a metalloid. Okay, so that jag is important. We've talked about chemical and physical properties. A physical property is one that can be measured without any sort of chemical reaction. With regard to conductivity, there's both thermal and electrical conductivity. Metals tend to be conductive, nonmetals are not. And then kind of put all 3 of those up there. Again, if you kind of pick on metals, metals tend to be shiny, lustrous. Malleable means you can kind of shape them. Ductile means that you can draw them into a wire. So I grabbed this off of the internet to kind of dissect in every box, and we'll be talking more about this information, but in every box, well, all periodic tables are different. But you have the symbol for the element. Okay, you have that big number, and we said the other day that big number is the number of protons. Number of protons. So Mendeleev, because what Mendeleev did, we pretty much kept today. When he organized it, it's by increasing big number, which is increasing number of protons in the center of those atoms. So we'll talk about this soon, that actually you're like, atomic number, well, why don't you just say number of protons? If you mean atomic number of protons, it's the same thing. And they use, for whatever reason, the symbol Z for the atomic number. This number down here is kind of fun. We'll definitely have to kind of take a look at this. That number in the case of beryllium, 9.01, I call that the decimal number. The decimal number, because usually it's a decimal. I think it's almost a decimal. The decimal number is basically how much it weighs. I'll go ahead and just put the weight. I can't spell weight. The weight of an atom of that type of element. And one of the things we're going to kind of kick around Thursday's lab when you look at the periodic table more closely is you would think they keep getting heavier and heavier and heavier, but there is actually one important exception where they don't. All right. So these are due, dun, 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 on, did anybody have a book I could borrow just to kind of take a look at? Okay. These will be due on Wednesday, but I didn't look at them. Thank you, but I bet they're okay. Ooh, cold. Yeah. I bet they're just fine and dandy. 52 says you're going to want a periodic table handy, obviously, and it gives some elements, and you're supposed to say, are they a metal, a nonmetal, or a metalloid? 56. 58, which are not main group elements. Now remember, main group elements are the group A. Main group and group A are the same. Which are not, she should be doing fine. Which are alkaline earth, that's 58. 60, these are going to go fast. There's 10 billion of them, but they're going to go fast. Which elements are alkali metals, so that'd be 1A for 60. 62, halogen, noble gas, or neither, so that's 7 and 8A. 64, you're supposed to say what the group number is for the element. That should be fine. And number 70, which element is, I like number 70, which element is a row 5 transition element? So row 5, that's period, and then transition elements group B. So it should be fun. Thank you. Just kind of intended to get you looking at a periodic table. So that's all I had for today. A movie and out early. Oh my gosh.